and stand up. Stand up and raise your hands up. Okay, stand still.
What?
No. You have committed a crime of CS 4774 of stealing the theft of exam paper.
The zombie's hitting me.
Now, stop the zombie. Now, you need to go with me, and then you have the right for an alternate. But if you cannot afford one will provide it for you. And you have the right to maintain silence. But anything you say will be and could be afforded for the court of law will be against you.
Can I kill the zombie first?
No! Hi, I'm Zihan Li, an officer of the Virginia State. Recently, there has been a huge increase of the burglary and the theft.
Hi, I'm scientist Heisenberg. In this project, we studied the factors that affect crime rate in Virginia. We used the national data to predict crime rate. In Virginia, the data is collected from 1992 to 2019. Data source includes CAGO, the United States Census Bureau, and the National Library of Medicine. Now, I will show you the source of our dataset. Take this dataset as an example. We have an extensive dataset in the tax burden on tobacco, covering the years from 1970 to 2019. It's a substantial source with over 10,000 rows of data. Our plan is to merge this with other data sources into a CSV file, which will serve as our original dataset for analysis. We choose the data because it is randomly collected and it is representative of the population. More importantly, there's a potential connection between this data and crime rate. For instance, higher tobacco taxes could lead to increased smuggling or illicit trade, potentially impacting crime statistics.
Okay, so in our project, we have tried several different machine learning models, and the best one seems to be random forest. We split the training and testing data sets with 80-20 split, and here are the results. As you can see here, the most important feature seems to be aggravated assault, and there's some also other features such as murder and robbery. So we'll pay more attention to those variables in later experiments.
So we use random forest to make our prediction. Look at this, the MS is so high for these variables. What happened? Useless. Hey, don't do that. Hey, we should use feature engineering and hyperparameter tuning, and we should fill the missing values with medians and use one hot encoder for the categorical variables.
Okay, I didn't know that. This is part of our code we used for our project. And we have trained several different models, but those are the three we finally decided to keep, which are random forest, decision tree, and SVM. We also did research to find the best parameters and do the cross-validation stuff. So the results are here. As you can see, the best result is 0.999 R square value for the SVM. So this is obviously our best model. It also has very low MSE. So we believe that this is the more accurate model to predict violent crimes from our dataset.
Different models have their pros and cons. Decision tree model and random tree model perform really well, but SVM has the best performance.
True, and the results can help us identify the crime rates in Virginia. And also, the policymakers can design more effective crime prevention strategies.
The overall project it aims to provide some valuable insights that can inform the policymaking process that targets to reduce crime rate, as you just mentioned, and improve the individual well-being and enhance the overall life and safety in our communities in Virginia.
Indeed.